Hello everyone, welcome back to my YouTube channel. So today is the lecture 2 for the series in soil basics, and in this lecture I'm gonna talk about the volume and mass relationships of soil components. In the previous lectures we have discussed a little bit about the soil components, that is your soil soil solids, liquid, soil moisture, and the soil air. And we have also discussed about a little bit about soil degradation, leaching, and some basic soil terms like soil profile. So today I'm gonna go into a little bit uh, technical aspects of soil, how as an engineer or as a plant water engineer, how will you quantify soil properties. So the title of today's lecture is as shown in this slide. But before that, I'm gonna talk a little bit about leaching. Yeah, in the previous lecture, I think we talked about the term called leaching. Uh, so the question is, what is leaching? Let's say there is a soil, and there is this many soil particles are here. So when rain occurs, suppose rain occurs, the rain will fall, or when there is irrigation or anything, if when water falls into the soil surface, it will take away some soluble soil nutrients like sodium or potassium along with it, and it will take these nutrients to the lower portion of the soil. So what happens is that when there is an excessive leaching means when there is excessive transportation of these soluble ions by water to the lower part of the soil, then there will be an chemical imbalance in the soil. What is this chemical imbalance due to excessive leaching? Okay, so leaching as a single term, we can say that it is a process. It is a process by which water carries the soluble nutrients from the soil to the bottom part of the soil, thereby causing chemical imbalance in the soil. So what happens is that when excessive leaching occurs, so many ions will be removed from the soil, like sodium or potassium. So many ions will be removed on the soil, so there is a lack of positive ions. So there might be possibility that some hydrogen ions may replace this sodium ions. So in that case, what happens? We said that the soil is degraded, means it loses its productivity. So that is the basic leaching. And the what happens is that excessive leaching can result in soil degradation. Okay, so with this being said, let's go to the technical components of soil. So whenever we say soil, or if we want to quantify soil, the basic thing that comes to our mind is, what is the density of soil? Density is nothing by definition, is like how much mass or how much weight is present per volume of the soil, right? Like what is the weight of the particle per unit volume of the particle, right? That is density. That is the basic definition of density. But as we know that there are three components of soil, like we have the soil solids, liquids, or soil moisture, as well as soil air. So we question, what mass will we consider, or what volume will we consider? So depending on what volume we consider, there are three types of densities. That is like total bulk density, or the weight density. Weight density, in practical terms, you basically take the weight of the wet soil and the volume of the wet soil. That is the practical terms in practically. And we have this dry bulk density, where you basically oven dry the soil sample first, and then you measure the weight, and then calculate the volume. That is your dry bulk density. And we also have another density called the density of soil solids, which is kind of relevant, which is like the specific gravity of the soil solids, like the okay, I'll explain this density of soil solids later. Okay, so let us now see what is total bulk density. Okay, before explaining total bulk density, let us draw the diagram. Suppose say I drew a schematic diagram where this is the soil solid, and this is your moisture, and this is your air. So this is basically the soil voids. So let's say the mass of the soil solid means the weight of the soil solid is ms and volume is vs. I'll explain this term again. And similarly for the soil moisture, let's say mass is mm and volume is vm. Similarly for soil air, ma and then va. So let's explain what is ms. Ms is like you okay, there is this soil particles is there is the void, there is the air. You only take out the solid particles in one container. You take out only the solid particles. Hypothetically, you cannot take out, or you say you open dried the sample and you measure the weight of this particle. The air doesn't have any weight, so it won't be a problem when you oven dry and wet it. And you that weight is called the mass of solids, because you consider only the solid, and the volume occupied by this solid is called the volume of solid. Similarly, if you could take out only the moisture, then the weight of that moisture is called mass of that is called the mass or the weight of the soil moisture. If you can take out only the moisture, and the volume occupied by it is the volume of soil moisture. Similarly for air also we have this ma and va, but air is the weight of air is negligible, so in our calculations or in future discussions we will neglect this. So from here we can say that okay, if we represent the total volume of soil by vt, then vt is like volume of solid plus volume of moisture plus volume of air. Similarly, mass of the total mass, if you represent total mass by mt, then it is mass of the solid plus mass of moisture, or say or water, and plus mass of air, right? But with mass of air we consider negligible, so we will consider ms and mb. So first let us see what is total bulk density. Total bulk density is nothing but your total mass by total volume. So your total mass is mass of solid plus mass of moisture plus mass of air divided by volume of solid plus volume of moisture plus volume of air. So this is negligible, so we neglected this term, and it remains like mass of solid plus mass of moisture divided by volume of solid plus volume of moisture plus volume of air. Right? That is right. Now let us talk about, well, now we have defined the total bulk density, and practically, as I mentioned before, how will we measure total bulk density? You just take a soil sample by a core cutter. You know, that circular metal bar, and then you just take the volume of that core cutter, and then you measure the weight of that soil. That is the total bulk density. That weight divided by the volume of the core cutter is your total bulk density. Now let us talk about the dry density. Dry density is like mass of solid. Here we will consider only the mass of solid divided by your total volume. This is nothing but your mass of open dry soil divided by the weight of the core, divided by the volume of the core cutter. So similarly, we have this mass of solid divided by uh, volume of volume of solid plus volume of moisture plus volume of air. That is your dry density. Okay, so now we have this density of soil solids, or this is a very confusing one. Okay, here density of soil solids. Let's say this is rho B, this is rho D, density of soil solids is rho H. This is the density of only the solid particles, like you say mass of the solid particles divided by volume of the solid particles only. So here you consider only the you consider the properties only the of the solid particles only, right? That's right. So I hope it's clear. So when you say there is another term called specific gravity of soil, gravity of soil, right? Where this in this term what you do is that you just divide the density of soil solids by the density of water, and you will get the specific gravity of soil G. And this term we will explain in next lecture. So for now you understand that the specific gravity of soil is nothing but the density of soil solids divided by the density of water, and it's a very important term for future calculations. So now we have discussed all the three types of densities we have discussed. What we have understood is that in all the equation we have put a reference, we have always use the mass of solid in every term and the volume of solids in every term, and we divided the density depending on whether the water is present, or whether you consider the mass of the water, or whether you did not consider the mass of the water, or the volume of water, or the volume of air. So these densities define give us a brief idea about the soil solids only, right? Yeah, it will give us idea how dense the soil sample is, or like how porous, and it will not porous, sorry about that, like how dense or how sparse the soil sample is, but it does not give an idea of how porous is the soil. How will you know how porous is the soil from these equations? No, you don't have any idea about that. So to define the how porous the soil is, we have two basic terms, which is very important. So we have the first we have this is to define the soil void. So we have two terms called the void ratio. Sorry about this. Void ratio, which is nothing but the volume of void by the volume of solids. Right, volume of void is nothing but volume of air plus volume of moisture, right, divided by volume of solids. So this will give us an idea of how much pores is present per unit volume of the solid in the soil sample. So you can say that the void ratio is like 0.3. That what does it mean? That means that for every one sample of solid, it contains 0.3 there is like 0.3% or 30% of them is void. But do you see any wrong with this term? The problem with this void ratio is that it's very difficult to measure these solids, right? Volume of solids, right? It's difficult to measure this volume of solids. So we have another term called porosity. Porosity, where it basically measures the volume, like how much volume of void is present per total volume. So when you say porosity, it's like volume of air plus volume of moisture divided by total volume, that is volume of solid plus volume of air plus volume of moisture. So porosity is an easy term to measure, right? And void ratio is little bit difficult, but we use it in our calculations, and it has physical implications that you will learn in the next sections. So let's represent this void ratio by E and porosity by N. and there is a classic relationship to turn porosity into void ratio into porosity, or like interrelationship, that is porosity is equal to void ratio divided by 1 plus void ratio. This is a very important term that you will need in the future lesson, and I won't go through the derivations of these equations, but uh, if if necessary I might have a different lecture on that, but for this course I won't go through the derivation of this equation. And also there is another equation which relates the porosity with the densities, and this is very important. Like you say that the bulk density or the total density is equal to, is nothing but it is equal to okay, I think I'll go to the interrelations. Okay, okay, let's say the okay, so the interrelationship, this is the interrelation between densities and porosity. So this total density is equal to the density of solids density of solid 1 minus porosity divided by 100. Porosity is in percentage, that's why it's divided by 100. So to make it easier, let's simplify it. That is rho t is equal to rho s, this is equal to 1 minus n by 100, or you can say that this is n is equal to 1 minus rho t by rho s into 100. So this is a very important equation where you say porosity is equal to the total density divided by density of solids into 100. So many times people confuse this density of solids with the dry density, and it should not be done. So just remember that this is the total density divided by density of solids into 100. Derivations, I won't go through it. Alright then, just keep these two interrelations in mind, that is porosity is equal to E by void ratio by 1. Oh, sorry, I hope it doesn't go black. 1 plus E, and void ratio is equal to 1 minus total bulk density by density of solids. Okay, I think yeah. Now we have finished about discussing about the voids. Now we will discuss briefly about the moisture, where we describe the moisture content in a soil. So there we have two quantities. We call it mass wetness and volume wetness. Both are basically the moisture content only. So in mass wetness, we say that so okay, the mass wetness moisture content is equal to mass of the water divided by mass of the solids. Yeah, this is in mechanical. In another book, this is like the dry moisture, like we consider this like a type of moisture content, which we say it's a dry moisture content, because we consider only the solids here. If we consider the total volume, then it will be the wet moisture content, and that is basically, those two are basically used in the for drying scenarios. So now let's see about the volume wetness. Volume wetness is nothing, is also moisture content, but you said that okay, but you said that it is like volume of water divided by total volume VT. This is like the wet moisture content. It's basically same. So just consider mass wetness, you consider mass, volume wetness, you consider volume. I think that's pretty much clear, yeah. So that's it for today, and I hope to see you in the let's wait. Before that, I'll give a summary. Today we discuss about the different types of densities. After that, we have discussed about how to quantify the voids in the soil, and also how to quantify the moisture in the soil. So we have discussed the interrelations between voids and densities as well. So please keep in mind those equations. Those equations are very important. Keep in the fingertips. And that's it for today, and I hope to see you in the next class. Thank you very much. Please subscribe to my YouTube channel if you find my content interesting. Thank you. Bye bye. Ciao ciao.